The rules of reflections in a coordinate plane. This is part 2 of our lesson. We're in 9.1b. If you didn't see 9.1a, just click the description and watch that one first. Reflections in a coordinate plane can be across the x-axis as the line of reflection. We can look at these two triangles and tell which one is the pre-image and which one is the image. The image has the tick marks. This is the reflection of this one. And a reflection can be across a y-axis as the line of reflection. We can see this is the pre-image, and this is the image. This was the reflection that's got the tick marks, see? And a reflection can be across a line of reflection in which y equals x. So this green line is our line of reflection. Point A is reflected across that line as A prime, and this line is where y equals x. So that means if y is a 1, then x is a 1. If y is a 2, then x is a 2, and so on. We'll talk about this more at the end of the video. And we can draw reflections in the coordinate plane by reflecting a figure with given vertices across a given line. And we can see that we've got the coordinates for M, N, and P. So without even looking at this drawing, we know there's 3 points. It must be a triangle, right? We're going to reflect it across the y-axis. So for point M, we've got a 1, 2. That's going to map as M prime as a negative 1, 2. N is at 1, 4. That's going to map as N prime, a negative 1, 4. And P is at 3, 3. It's going to map to P prime as negative 3, 3. Do you see what's going on here? Look at the x values for the image and the pre-image. Do you see what's happening? Because we reflected the figure across the y-axis, the x values map to their inverse. So we have a 1, and a 3, and then we get a negative 1, and a negative 3. And the reflection of xy is negative xy. And if the labels are going clockwise, like here we have M, N, P, so it's kind of going clockwise, the reflection, the label of the reflections will be going counterclockwise. M prime, N prime, P prime. See, it's going the other way. Here we've got the points, the ordered pairs for A, B, C. We need to reflect it across the x-axis. And A is at a 1, 2. It's going to map to A prime as a 1, negative 2. See what happened? B at 1, 4 is going to map to B prime at 1, negative 4. Look at that. And C at 4, 2 is going to map to C prime at 4, negative 2. So because we reflected the figure across the x-axis, the y values map to their inverse. So the reflection of xy is x, negative y. Okay? We've got one more rule here. We've got points A, B, C, D. Because there's 4 points, that tells me it's a quadrilateral. And we need to reflect it across y equals x. So A is at 2, 2. That's right here. It's going to map to A prime at 2, 2. B is at 5, 2. Right here. And it's going to map to B prime at 2, 5. Now, do you see what happened here with B? You can't tell with A because it's on the line of reflection and the x and y values are the same. But when we get to B and C and D, you can see what's happening. We've got a 5, 1, and it maps to a 1, 5. We've got a 2, 0, it maps to a 0, 2. Because we reflected the figure across y equals x, the x values and y values swapped places. So the reflection of xy is yx, see? So when we're going across a line of reflection as y equals x, they're going to swap places. And points that are on the line of reflection map to the same ordered pairs. Okay? So, this is it in a nutshell. We can reflect the given vertices across the given line without looking at a coordinate plane by using these 3 rules we've just learned. xy is going to map to negative xy across a y-axis. xy is going to map to x negative y across the x-axis. Do you see what happened? If we're going across the y-axis, the x values get affected. If we're going across the x-axis, the y values got affected, see? And xy is going to map to yx across the line y equals x. So if you haven't already, pause the video and write this in your notes because this is going to be really helpful for you, okay? So here we've got some more. We've got ABC. That tells me it's a triangle. There's 3 points. We need to go across the x-axis. That tells me we're going to have inverse y values. So for A, we've got a -2, 1. For A prime, we're going to have -2, -1. See, it's the inverse of the 1. We have B, 2, 3. It's going to map to B prime to -3. And the y value for C, this 2, is going to be a -2. And we have RST, that's another triangle. There's 3 points. It's going across the y-axis. That means we're going to have inverse x values. So for the x values, we've got a 0, a 2, and a 3. And they're going to map to a 0, a -2, and a -3. See, 0 is the inverse of 0. Okay? Now we've got MNPQ. And we need to map it across y equals x. So because we're doing y equals x, we're going to have x and y values swap places. So everything that we had in the x value is now going to be the y value. And everything that was the y value is now going to be in the x value's place. See? And if you notice, it went MNPQ. It didn't go MNOP because 0 gets confused with that O. So they don't usually use that in labeling. So don't use an O in labeling. Just skip over it and go, MNPQ or something like that. All right? Now, remember the image of a reflection is congruent to its pre-image. We talked about that in the previous video. And one transformation of A is labeled as A with this little tick mark. That's A prime. If we then do a transformation of A prime, it's labeled as A double prime with 2 tick marks. And if we transform A double prime, it'll transform to A triple prime. See? So what happens is, if the blue one is the pre-image, our first one, and we make an image of it by reflecting it across X, we'll have A prime, B prime, C prime. If we reflect the pink one across the y-axis, now we've got a second image. So we reflected it, and we reflected it again. So now it's A double prime, B double prime, C double prime. If we reflect it again across the x-axis up to this brown one, we'll have A triple prime, B triple prime, C triple prime. And that tells us from the prime notation, these tick marks, how many times it's been transformed. See? So I want to explain that y equals x for those of you who need it. For a line where y equals x, all the x values and y values are going to be the same. And the line will rise to the right through the origin. Doesn't matter, even down here, if it's a -5, that's a -5, see? Now, if the line were to fall to the right, y would not equal x. So for y to equal x, it has to look like this, okay? If we're at a -2 for x, that's going to be a +2 for y. So this is where y does not equal x, see? So it has to be this way, all right? And from our previous video, if we don't have coordinates to draw a reflection, we can make lines from the vertices of the pre-image that are perpendicular to the line of reflection, and then we measure the distances. So if this is 4.5 centimeters, we make a point 4.5 centimeters here. If this is 2.5 centimeters, we make a point 2.5 centimeters on this side of the line of reflection, 5 centimeters, 5 centimeters, and we mark those points and we connect the points, and we've made a reflection without any ordered pairs or coordinates, okay? You should watch the previous video if you don't understand that or if you want to see more about that. And remember, also from the previous video, an isometry is a transformation that doesn't change its shape or size. So reflections, translations, and rotations, flips, slides, and turns are all isometries, okay? Our next lesson, we're going to talk about identifying translations in the first part of the lesson, and then in the second part of the lesson, we're going to talk about drawing translations in the coordinate plane, okay? And we're going to talk about rotations after that. We're going to talk about dilations after that, all right? So that's all Chapter 9. It's all extending transformational geometry. So remember the 3 rules. I hope you wrote them down. I hope you're having a great day, and I'll see you next time. Bye.